Number 5. What is the ratio of thicknesses of crown glass and water that would contain the same number of wavelengths of light? All right, so the whole idea is this. We first have to know some of the indices of refraction here. So for crown glass, the index of refraction here is 1.52. All right, that's the N for crown glass. And for water, it's going to be 1.33. Maybe if you want to add another 3, that's fine. So the whole idea is this. The higher the index of refraction, the shorter the wavelength is going to get. I mean, that's according to this formula. All right, over here on the right-hand side. So let's pretend you have a wavelength like this, really long, okay? And then as soon as it hits now the boundary between, let's call it a vacuum up there, and now crown glass, what's going to happen is it's going to speed up. Oh, excuse me, not speed up. The wavelength, it actually slows down. But the wavelength will become shorter. Okay, so hopefully that illustration's okay there. Obviously, you can tell, you know, this is one full wavelength there, and now this is like one full wavelength, okay? So what's going to happen now is I can take now this same wavelength, all right? So let's copy it, and let's pretend that this light is now incident upon the water boundary. And what's going to happen is, since this has a lower index of refraction, the wave will compress, but it won't compress as much, okay? Now, what I want to do here is I want to try to find the ratio between these two thicknesses, all right? So essentially, let's call this, you know, the thickness, let's call it D sub C for thickness, you know, the distance for crown glass, or you can call it T, it doesn't matter. And let's call this the thickness or the distance for then the water, okay? So in order to find now an expression that represents the, let's say, number of wavelengths, okay, because that's what I'm trying to say, same number of wavelengths. So what I realize here is that this, you know, I'm going to start off with a mathematical relationship. It just says that the number of wavelengths in, let's say, the crown glass has to equal the number of wavelengths in water. Now, the wavelength doesn't have to equal one another, but the number of them have to equal one another. So how would I come up with a you know, let's say a relationship here between the thickness of the glass and the number of wavelengths that are in that glass? Well, pretend you had this kind of thickness here, you know, this distance, and let's pretend you knew 1, and let's say it went to a half or something. You know, 1.5 wavelengths there are here, okay? So if I now knew the total, pretend that the total here was 10, okay? Pretend the total here is 10. And then I'm going to give you, let's say, this wavelength distance now, because the wavelength is one full up and down cycle, right? I don't know what happened there. But let's say it's one full then up and down cycle, right? So it's going to be, I'm going to give this to you, it's about 6 2/3, or about 6.66, okay? 6.66 meters, 6.67 meters, okay? This is 10 meters. If you knew the overall thickness, or the distance, and you knew then the wavelength, how can you find the number of wavelengths here? Now remember, there's 1.5 wavelengths. So you might say, well, how do I manipulate those numbers? Oh, wait a minute, is 10 divided by 6.67 going to be equal to 1.5? I don't know, let's check it out. 1 divided by that value, 6.6, blah, blah, blah. Oh, wait, 1.5, right? So what did you just realize? You just realized that we can take the thickness or the distance and then divide it by the wavelength. And that will tell us then the number of wavelengths there are. So if this is for crown glass, and this is the wavelength through the crown glass, and then this is the number of wavelengths for crown glass. So I just created now this little relationship. This would also be true then considering the water, right? This would have been the thickness of the, you know, water divided then by the wavelength in the water will then equal the number of wavelengths, okay, in the water. So what I realize now is, since I created this equation before, right, it just comes from the nature of the problem, I can now substitute these fractions on in for each of their variables. So we're going to have dc over then xc is going to be equal to dw over, great drum kit, by the way. Love my DWs. For all you drummers out there, you know what I'm talking about. For everyone else, Sorry. So basically what I want to do here is I want to find the ratio of the thickness of crown glass to that of water. Okay? So I want basically now what I want to solve for is the thickness of crown glass to that of water. That's what I'm solving for. So I realize, oh look, I can just cross multiply these two, and there we go. Okay, I guess I can solve my problem now, but wait a minute, we don't know these numbers, right? We don't know them. So we can't, we're not done yet. But what do we know? We know the indices of refraction, or the indexes of refraction. I don't know what the plural is, but who cares? That's why this is physics and not English. So now what we're going to do is we need to figure out a relationship, all right? And, oh, wait a minute, that's what we've been doing for the past couple of problems. It says that the wavelength in a particular medium like crown glass will be equal to the wavelength in a vacuum divided by then the index of refraction in that medium. So if this is crown glass, right, I can now take this. Isn't this problem great? I can now take this and plug it in for this, right? So I'm going to get then dc over dw is going to be equal to the wavelength of the light in a vacuum divided by then the index of refraction in that crown glass, divided then by, it's going to be the same thing here for the bottom, just now the wavelength in a vacuum divided by then the index of refraction in the water. Now mathematically speaking, all right, you can take this numerator fraction, multiply it by the reciprocal of the denominator, but at the end of the day, this is what's going to happen. Those wavelengths will cancel. We definitely want to come up with shortcuts by this point, right, in physics, because these problems become long enough. And then we need now the index of refraction of water. That goes on the top, divided then by the index of refraction in crown glass. And finally now, I have an equation that I can use to plug in. So now we need the value in water, 1.333, divided by the crown glass, 1.52. Take out your calculator, 1.333 divided by 1.52, and voila, it works out to be now the ratio here, dc over dw, is going to be equal to 0.877 or so, okay? Depending upon the values you use, all right? Some tables might be a little different, but that's it, all right? And yeah, so guys, thanks so much for tuning in, and hopefully that makes sense based on what we talked about, how the wavelength will compress more in crown glass than it does in water, so this should be smaller, all right? But anyway, thank you so much. I appreciate it and hope this helps. By the way, check out some more of our problems. All right, we got a whole bunch of other subjects out there, pre-calculus, chemistry, and more coming. We solve specific problems just like we're doing here in physics. All right, we go through the OpenStax books. If you're not using it, it doesn't matter. Go to the website. They're free. Download the book and find similar questions to the ones you might have. And I guarantee you'll find a very similar one, if not almost identical. And then you'll know how to solve it. All right? Thank you so much, and we'll see you soon. Take care.